Welcome, Professor Bright here, and this is going to start our video series for this course. And we're going to start by looking at solving linear equations. And just so we're all on the same page, what a linear equation is anything that can be written in the form ax plus b or ax plus b equals 0, or it could be equal a number, doesn't matter. And those a's and the b's, they aren't specific things, they can change, and so it's just they're real numbers, a and b, but x is our variable. And really, when we write this, what we're trying to do is know what the value of x is. And so, we can get started, and we've probably seen this in our past at some point. Might have been a while, but here we go. So we want to figure out what the value of m is, right? But the problem is there's two m's in the example that I chose, and so we need to figure out the value of m, and there's only one. So we need to kind of manipulate the equation a bit. So what I'm going to do is take the 2/3 and distribute it to each of those quantities inside, so to the 9m and to the 12. And so that 2/3 would combine with the coefficient of 9 via the operation of multiplication. So it'd be, I could write it out as like 2/3 times 9m, and then minus, and then 2/3 times 12. I could write it out like that, and then leave the left-hand side unedited. So it would be, a plus 2m. Combine 2/3 times 9 would be 6m, and then minus 2/3 times 12 would be 8. You can double check that arithmetic on your own. Is equal to 8 plus 2m. Okay, now ideally when you solve this, it would look like m equals a number, right? So that there should be just one m present overall, and so we would need to move the m's to one side. I'm going to move the m to the left-hand side, so I'm going to move the 2m to the left-hand side, and I'd have, 4m after I combine like terms, minus 8 is equal to 8. And now I'm out of room here, so I'm going to come up over here. Next thing I would do is add 8 to both sides because I want the variable isolated. And so when I come up and do that, I'd have 4m is equal to 16. And then to maintain equality, right, I want to get rid of the 4, and the operation is multiplication. Undo that with division. So divide by 4. And m would then equal 4. Okay, and really what I should do is I should double check that. So I could, after my work, and this is most commonly skipped, but to check if a solution is a solution, right, what you would need to do is do 2/3 and then 9 times 4 minus 12 is equal to 8. So substitute that back in for each occurrence of the variable. I'd have 2/3, and then this would be, 36 minus 24, minus 12, I was already jumping to the answer, is equal to, and then this would be 8 plus 8. So this whole thing is 24, and 2/3 of that would be 16. So I'd end up with 16 is equal to 16, which does indeed check. So if it is a solution, you should get the same thing on both sides. All right. So as we went through this, we kind of just made it very simple. But overall, what did we do? We simplified each side as much as possible, right? That was a distribution. Okay, and then PEMDAS, etc. Next, I collected variables on one side and non-variables on the other, right? That was what I was doing here in these two steps. And then step 4, made the coefficient of the variable, so coefficient is the number in front, right, that equal to 1, and then I check the solution. All right, so that is how we solve a linear equation. Here is one more example for you to try, and I will leave all of this on the screen. I encourage you to pause the video, try it out, and in a moment I'll solve the solution. And here is the solution.